Good afternoon, everyone. Welcome to this Advanced Steel webinar where we're going to be looking at Revit and Advanced Steel collaborative workflows, specifically for modular buildings. My name is Rob Merriman. I'm one of the application engineers here within the structures team at Graitec. I've been at Graitec for nearly 2 years now, but I've been working in the metalwork and steelwork industry since I left university. So before joining Graitec, I was a steelwork draftsman using advanced steel in 2 different subcontract drawing offices, one with metalwork, one with mainly structural steelwork. And now at Graitec, my focus is training, support, customization, things like that with advanced steel. But then recently, in the last 6 to 12 months, we've been looking at working more with the AC collection. So I now work with Revit, Navisworks, and just trying to look at workflows to maximize the AC collection for you guys. So if you do have any questions about today's webinar or anything else relating to advanced steel, Revit structures, steelwork in Revit, modular buildings, just anything in general, you've got my contact information there on the screen, and it will be at the end of the presentation as well. Okay, so we'll get cracking. So before we actually get on with today's webinar, this is the last webinar in this sort of quarter, this series. So we'll just go through what we've done before. So the first one we did was the Advanced Steel Project Explorer. We've done another one on Advanced Steel and Plant 3D collaborations. We've done one with Navisworks, looking at planning your steel installation in Navisworks. I've done just a general overview on the Advanced Steel and Revit integration, so just more of a general structure. Today's will be focused on modular buildings. And then last week I did a webinar on checking your Advanced Steel model to eliminate drawing errors. And today's is obviously the Revit and Advanced Steel workflows for modular buildings. In your little webinar menu, you do have the option to download a handout, and all of the links are correct in that handout. So if you have missed any of the webinars, you can download the handout and the links are embedded. It'll take you straight to those webinars. If there's any other webinars that you've missed, please send an email to marketing@graitec.com and they can provide you with the list of recent webinars or any webinars that you might be interested in. So there's a few more webinars that we've done on the links between Revit and Advanced Steel. So like I said, today is going to be an overview, probably going to be about half an hour, but myself and John Bennett last September, October time, we did do 4 webinars about 40 minutes, 50 minutes long each, looking at all of the tools between Revit and Advanced Steel. So we did a webinar on structural steel for Revit users, so using connections, manually modeling bolts and plates and things like that. Then John broke down the transfer mechanisms between Advanced Steel and Revit into 2 webinars, and then I looked at taking the Revit model and producing fab drawings and things like that. So today is going to be a real quick overview, but the links are there again to go back and look at the webinars that we've done in the past. Oh, and sorry, there was one more. There's the overview I did a couple of weeks ago. So today's webinar, we're going to look at workflows for modular buildings. So we're working with a few clients at the moment who are mainly using Revit to do all of the work for their modular buildings, but they are now starting to see the benefit or investigating the benefit of Advanced Steel, because doing fabrication drawings in Revit is quite time consuming and a manual process. So now that you have Revit and Advanced Steel in the AEC collection, you can benefit from using both bits of software. So today we're going to look at the possible workflows. So what software to start in, where the detailing is going to be finished and when to transfer it. We'll quickly touch on content creation. So I'll just give you a few tips and tricks and some hints that we've picked up on structural family creation inside Revit, and then Advanced Steel, creating those same sections in Advanced Steel. We'll look at a couple of the steel connections in Revit and what we can do in there. Then we'll export from Revit to Advanced Steel. We'll give you a flavor and a rundown of what Advanced Steel can do for you, and then we'll finally send it back to Revit. So possible workflows. So workflow number one is we're going to start in Revit. All we're going to do is we're actually just going to put the members in. So we're not going to put any connections on. We're going to sort of take it to a level of detail, I think it's about 200. So we're just modeling the members in the correct position. Then we will send it to Advanced Steel, where we'll put all of the connections on, run all the fabrication details, run all of the lists, etc. And then finally, when that's finished, we can send it back to Revit. Another workflow you could look at is where you use the Steel tab in Revit a little bit more. So you model all the members, but you model all the connections, or as much as you can do within Revit. Then you send that finished model to Advanced Steel, where you run the fabrication drawings and the lists and everything like that, and then finally send it back to Revit for the finished model. Or if you're an Advanced Steel user, or the only thing you're doing in Revit is actually setting out the members, what we could do is actually just do the whole thing in Advanced Steel, so we can draw the members, put the connections on, run all the fabrication information, NC files, fabrication drawings, and then send it back to Revit. So what I'm going to do, I'm just going to run a quick poll for you guys just to see what you're doing at the moment. Is it just something you're interested in? So if I just launch this poll, if you could just take a minute just to answer the questions in there, just to if you do produce fab drawings, what do you use? Are you manually using Revit, manually using AutoCAD, automatically using Advanced Steel, subbing the whole process out to someone else, or actually none of the above and you're just interested in these potential workflows? So I've got 50% of people have completed the poll. If you haven't, if you could, even if it's none of the above, if you could just complete the poll for me, just so we can see what people are using. Okay, we'll close that poll. So it's mainly none of the above, so I'm guessing a lot of you are just here to see the workflow. Some 15% of you are subcontracting out the work, and 20% of you are using Advanced Steel for it. So that's quite interesting. Okay, we'll just have a quick look at content creation, because if you're transferring between Advanced Steel and Revit, a lot of the modular buildings use C channels that might be fabricated in your own workshop or bought from a supplier, and they're not standard hot rolled members. So with your Revit structural family creation, it's really important that you create this content properly. Otherwise, importing and exporting, members just come in the wrong way, the position isn't correct. So when you're creating, everything to transfer between Revit and Advanced Steel needs to be done as structural framing or structural columns. I've embedded some links for the Revit 2020. So we've got hot rolled steel shape dimensions, cold form steel shape dimensions. We've got other shape dimensions. And what we found through just testing and trying different pieces, it's always best just to follow everything exactly on the Autodesk website. So it has all of the dimensions needed. I've even created them with the same parameters in, so HB, H1Z, Y. What we've also found is that this C profile with lips is the toes are on the right hand side. We've even found that if you put the toes on the left hand side, so you have it created the other way, it can cause problems when transferring backwards and forwards. And what we would say is create one family, draw it as a 2-meter beam, try exporting it to Advanced Steel, and then in another model, have just a plain beam and then a plain beam with a connection on, to make sure the connections work, because if you don't have it set up properly, the steel connections won't apply. And also, when you apply a steel connection in Revit, it creates a steel fabrication format, and that does behave differently on the import and export. So before you go and create hundreds of different families, I would strongly advise you do the first one, draw a straight beam, draw a beam with a connection on, and export just those 2 items before you go any further, just to make sure it's all working properly. And then with advanced steel, they're not called families in advanced steel, they're called user sections, but the same principles apply. We have a link here for creating user sections, but if you've done it in Revit following this direction, so we're towing from left to right, we would advise that you do the same in advanced steel. So it's a little bit different in advanced steel. You've got a few extra layers and things to create in there, but the process is the same. You still need to create it properly, and then the transfer will work correctly. Okay, so I'm just gonna crack on and do some live demos in here today. So I've kept it really simple for today, just because when you start applying connections and transferring on bigger models, it does take sort of 5 minutes or so. So I didn't want to sit here while you're all waiting for transfer. So I've got a simple modular building. So this is going to be a ground floor of a school. So what I have is I have 4 modules. I've just created some groups in Revit: ground floor 01, 02, 03, and 04. And they are made up of, it's a hot rolled frame on the end. So I've got some rectangular hollow section columns, some PFC supports, and then I've got custom families. So I have, if we go into this, I've got a cold rolled steel section. So if you can see in here, I've created that, going from left to right. I've got my B and my H as I had on the screenshot in the presentation. So this is I think it's a 250 by 70 by 3, and then I've got a 120 by 50 by 3 in here. And then if we have a quick look in my advanced steel, I'll just show you that I have created those same sections in advanced steel. So these are my advanced steel sections, again created with the same orientation, just created using the advanced steel format of creating families or user sections. So the way I'm going to show today is I'm going to just send this model with no connections into advanced steel, do the detailing in advanced steel, run my fabrication drawings and my automatic output, and then we'll bring that finished model into a new file, just because the synchronization again takes quite a lot of time. It takes about 5 to 10 minutes. I'll quickly show you the steel connections in Revit. One thing I need to do first is steel connections don't work on groups. So I'm just going to ungroup these items. We'll go to the steel tab, see if I have any loaded in. So I don't. So we'll do what I would call a fin plate. In Revit, that is called a shear plate. So what I'm doing here is I'm loading the connection into this project. And then I can go to apply that shear plate between the box section column and the C channel. Remember, that C channel is my custom family, but because I've set it up correctly, that will still work. Now what we have to do here is we have to be in level of detail fine, and you can see that that has now put a fin plate connection on. What we can do is we can modify the parameters of that connection. So I want 6 bolts and I want it to be connected with countersunk bolts. So we can click the modify parameters and I get a dialog box. So we can go to the plates and the bolts tab. what I'll say is I don't want a little notch on the corners. For the bolts, we can make them M16s. We can make them countersinks. And then what we can say is we want them 50 from the end of the beam. I want 3. I want them 50 mil apart. And I want a 50 mil edge distance. And then vertically, what I can say is I want that in the middle of the plate. 100 mil spacings is fine. So that will, if I just go to a wireframe, give me the plate, the weld has been modeled in there, and the bolts have been modeled in there. So what we could do then is we could copy this around. So in 2020, there's a new function called propagate joint. So if I select the connection and right click, I have the propagate connection option in here. So what that will do is that will find all of the scenarios where I have this section column connecting into this section C channel, and it will apply that connection to all of those places. So we can very quickly apply all of the connections or propagate the connections around the model. We don't have to copy it to all scenarios, mirror it, do a multiple copy. We can do that and just let it tick away, and it will fill the model with joints for us. So like I said, I'm not going to do that today. I'm going to show you some of the tools in Advanced Steel, which everything from the Steel tab has come from Advanced Steel anyway. So you can either do it in Advanced Steel or we can do it in Revit. So what I'm going to do, let's just see, go back a couple of steps. I'm going to export this model to Advanced Steel. So that is done in the Add-ins tab. So you need to install the Advanced Steel extension. And we'll just check the settings just to make sure there's nothing in there that I need to change. No, that's fine. We'll just apply the settings. And what we'll do, we'll export this model. So I'll put it on my desktop for today. That creates an SMLX file of the model, which we can then import straight into Advanced Steel. So that has finished. So I can go to my Advanced Steel. I will start. I've created a custom template. There's a couple of little things I've tweaked in here. It's mainly just colors and things like that. We'll go to the Export and Import tab, and we want to import from Revit. So we'll hit the Import button onto my desktop. And we'll just give this a minute. You can see in the bottom left the import status. You can actually see, if I could zoom out, it's actually building the model for me. So we'll just wait for that to finish importing. And there we have my 4 frames. Because I have the content created in Advanced Steel, it's mapped my custom C channels. Now the first time you do that, you will have to find that section in your Advanced Steel. Once you've done it once, so I'm working in the 2020 versions, once you've mapped it once for that particular version, that's it done. So that's why I didn't have to map anything today, because I was just running a few tests and a few experiments on this file last week. So everything is mapped for me. So now that we've got this in, we can apply connections. So the same as Revit, we have the connection vault. In Advanced Steel, you don't have to load anything because it's a steel detailing package. Everything is preloaded in here. So what I can do is I can find, in Advanced Steel, it's called a fin plate connection. We select the main beam and we select the secondary beam. and it will apply the connection for me. Now what I have done is, last week I was setting this up and I was playing around with different things. All the settings that I changed in Revit, I've actually set up last week in Advanced Steel, and I saved in the library, so that if we look at my library entry, there's an RM 250 by 70 by 3 channel with the 100 by 50 box section. So if Advanced Steel finds those two sections, it will automatically apply that connection automatically. So I don't have to go through the dialog and set it up. So that will work on every project where I've got those two elements. So you can very quickly build a library where you don't have to go through the dialog and change it every time. We'll just apply a couple more. So what we found with the clients we're working with and discussing this workflow with is that these box sections need a stiffener on the bottom. So we have a stiffener box column joint. So I can choose the column, choose a point. And again, I've set up a library entry for 100 by 50 bottom and 100 by 50 top. So what it does is it puts the plate on for me, welds it to the column, and then puts a little chamfer in the corners. And this is where my preferred workflow would be to do the members in Revit and do the connections and things like that in Advanced Steel, because what I can do is I can select these items now that I've put the couple of connections on, and I can run a clash check. And this checks all the elements against each other, including things like the bolt spacings, whether you can get a socket on the nut if there's enough room, whether you've got enough room to actually get the bolt in and out. So by doing the connections in Advanced Steel, I can put one of them on, clash check it before I copy them around the model. And a new feature in Advanced Steel 2020 as well is we do also have that propagate joint that we have in Revit. So we can apply that connection to all of those scenarios in the model. I'm not going to do it today. I've got a little bit of a blue for those of you from the UK. I've got a Blue Peter one I did earlier. I'm just going to look at a couple of other things we can do in here. If we had a modular building with multiple levels, what we've found with the few companies we're working with on these workflows is that the cap plate in the top of the column needs a captive nut, so a nut welded on the underside of it with a hole in, obviously so we can bolt the two columns together. So the stiffener box column won't put the nut on automatically for you, but what I have is I have a library entry for the top that will put it inside of the column. If I just go back to a realistic, so it's put a hole in automatically for me, but it hasn't put the captive nut in. So what we can do in Advanced Steel, and again you can do the same in Revit, is we can set up what are called custom connections. So we have all of these building blocks, and any connection in Advanced Steel or Revit, just use shortenings, bolts, welds, plates, things like that. So we have all of these building blocks available, and I can roll it into one custom connection. So what I can do is I can say insert a custom connection, and I have my 100 by 50 top complete with captive nut, and it just says select the box section. What it does is that puts that connection on automatically, but I've also created a nut in there, so that nut is welded on automatically. And again, we could copy that round. So what I'm going to do, just to copy it round, it would take me about 20 minutes. So I don't want you guys to sit here for 20 minutes while I copy all of those round. So I do have one that I had finished earlier on today. So we'll just wait for this to open. So what I've done in this model is I've put all of the connections on, I've clash checked it all, I've copied it around to all the 4 modules. When it does open, I will just show you a couple of extra bits and pieces that I've done in there. It is still thinking about it. It shouldn't take this long to open it up. but I basically have a finished model. It's not liking what I'm doing, so what I might have to do is just crash out of it. I probably shouldn't have Advanced Steel and Revit and all the other bits and pieces I've got running at the same time, so just give me 1 second. It's come back to me just as I was about to close it down. So what I have in here, I've just changed a couple of colors, but I've got all the connections on. And what I've done for the frames is, if we look at one of these columns, I've used the lot and phase option in Advanced Steel. So I've put ground floor 01, 02, 03, 04. So when we come to run fabrication drawings and run the lists, I can show you what we can do with those, because this is slightly different to the standard steel build, where you're not delivering assemblies to site, you're delivering the modules to site. So you guys, when you're building it, need to know what item goes with what module. So what we need to do is, just before we run the fabrication drawings, I just need to do one very important check and make sure that everything has a name. So in Advanced Steel, that is called the model roll. So the model roll does two specific things. It drives our numbering system, but more importantly, it drives our fabrication output. So if something doesn't have a model roll, it won't be given an appropriate drawing. So in my template file, I have a search set up for looking for items that don't have a model roll, and it will highlight to me straight away the items that just are missing the model roll. So we will go to this view, and we can, in fact, they're all beams. And that's all we have to do, is we just have to set the model roll to beam. So we'll turn everything else back on. Okay, so this is where, if you guys are doing it manually at the moment, or you're subcontracting it out and someone else is doing it manually, this is where using Advanced Steel could be hugely beneficial to you, because for the guys that we're working with and we've spoken to, what they're having to do is they're having to look at everything in the model. They're manually having to decide if items are the same, if items are different. And what Advanced Steel will do is we can run what we call the numbering on the model. By hitting OK on this, it will compare every section, every material grade, every coating, every bolt position, every weld position, every hole, every notch, it just compares everything in the model against each other and applies numbers to everything. So if we have items that are the same, it will, if we have 10 items that are the same, it will call them B1 or C1. And if they're shafts and fittings, M1 and F1. So you can see at the bottom of my screen, it's scanning the model to check for the numbering. So what it's doing, it's just comparing every component against every other component to see what can be done. And when I first started as a draftsman, I was working in 2D AutoCAD, so I had to do all of this myself. This is where it can take hours, and because it's been done manually, that's where errors can creep in. So I've got 120 B1s, so those are my tie beams because I've made them all the same. I've got 8 gable frames, and then 8 beams running, or 16 beams running between them. What we can also check in Advanced Steel is we can actually check before we go any further what's welded. So these end frames are welded together. I have a function in Advanced Steel that will show me what's attached in the workshop. So you can see the 2 columns are red, the horizontal PFCs are red, and the fin plates are red. So it's what I'm doing to check the model before I actually fabricate. So I'll just hit save now that we've numbered. And what I need to do now is run my fabrication drawings. So we'll go to run the parts. So I'll just get this running and then I'll waffle on while it's doing it in the background. Again, this is where if you're currently doing it in Revit or AutoCAD, this is the manual work. So you'll have to create the extra sheets, take all the bits out you want, then add your dimensions, add your hole information, add all the quantities. And again, because it's a manual process at the moment, if you're just using something like Revit or AutoCAD, it's going to take quite a long time. So what Advanced Steel is doing now is at the bottom of my screen, it's running. So the process I chose was this one here, all parts A4 to A1 single BOM. So it's running all of the parts. It's going to start on an A4 sheet, and then it is going to see if it can fit the item on at 1 to 1. If it can't, it'll go to 1 to 2. If it can't, it'll go to 1 to 5. If it can't, 1 to 7.5, 1 to 10, 1 to 15. If it gets to 1 to 15, it'll then go to an A3 sheet, repeat the process, an A2 sheet, and then an A1 sheet. Single means it's one item on one sheet, and then a BOM is a bill of material. So it will give you a breakdown. It will give you a little table in the top right-hand corner. Where Advanced Steel is different to Revit is that everything you do in Revit is created within the project file. What Advanced Steel does is it creates everything separately. So while these are running away, I will just go to that folder. So I'll show you what Advanced Steel does. So my model is called G5682-Steel. Let's just see, that's still going. So as soon as I hit the create part drawings, Advanced Steel automatically creates this folder structure for me. So it creates a folder with the same name as the model. Then it creates a folder called details, and this is it creating all the part drawings. Just taking a bit of time on my machine today. And these drawings are separate DWG files, but they are separate intelligent DWG files. So everything that is shown in those drawings is taken automatically from the model. So if we were to change a length of a beam or change a hole position, those drawings we could update automatically. So again, it's taking out the manual processes that if you were just using Revit or 2D AutoCAD to do your fabrication drawings, is taking out those manual processes. So we'll just let it crack on with that. And then what we'll do is we will run some NC data and some lists and things like that, and then we'll send the model back into Revit so you can see all the bolts and the connections and things like that. So it's still, if I bring that folder back, you can see that there were a couple there a minute ago. It is creating them. My machine just seems to be on a bit of a go slow when I'm on a presentation, which is always good. What we'll do, I won't run I think there's only 4 assemblies actually. We'll run the assembly drawings because I want to show you guys what you will get automatically out of the box. What I might do is when we've sent this to, I'll run the fabrication drawings once I've exported it to Revit. So we'll import it to Revit and then I'll leave Advanced Steel ticking away to create the drawings so that I'm not keeping you guys any longer than you need to be. should be nearly finished with the drawings. Normally I could run about 200 drawings in this time, so I think I'm going to need to give my computer a bit of a tidy up. Okay, so that has created those drawings. So we'll, like I said, I'll show you the part drawings. I'll run the assembly drawings while I'm once I've gone back to Revit. So these are all my fabrication drawings. So if we have a look at F1, for example, that's one of my end plates. So what you will get is you get a title block in the bottom right that pulls all of the information from the file. You get the fabrication detail, so the actual hole positions, the hole size. You get a bill of materials in the top, which tells you what section it's from, its material grade. You also get a phasing box, so it tells you that in ground floor 01, there are 60 of them. So it breaks it down that you need 240 in total, but there are 60 in each phase. Same with the other end plate. So they're quite simple, but it's these drawings that it gets done automatically. If we look at some of the, I mean, this is quite a simple model, but it's this that if you had 50 frames would take a long time to work out what's happening on each one. What we can do next is we can run NC and DXF data. So if you've got a drill and saw line, I can hit this button here to run NC files for everything. And this should take literally a second or two. And what Advanced Steel has done, if we go back to that folder, there is now a DSTV folder, and there's an NC file, and here's all the NC information for all of those parts. So we could send the plates to a drill and saw line, to a profiling machine. We could send the beams to a drill and saw line so that we can get all of that pre-cut. And all the workshop's got to do is weld it together. What I will run for you is the next benefit are the lists that Advanced Steel can run. So I can just click a button. I've clicked it on the other screen, so I'll drag it across in a second for you guys when it'll let me. I'm running at the moment an assembly list, so you can see in the bottom right it's creating a model extract. What I'm doing here is I'm running an assembly list. So it will help the workshop when they're manufacturing the frames. It will actually give them the frame number, tell them the total quantity, and it will also give them a breakdown of all the individual pieces they need to make that frame. So when your workshop are manufacturing, they can tick off or highlight or just cross out when they've made certain bits. It helps the foreman go and actually get the pieces of steel that they need, so the yard isn't full of steelwork and they're trying to measure and bring in all the different bits and pieces they need. If you sent it to the drill and saw line, it'll be marked with a correct shaft and fitting number anyway. So I will just run you a couple of lists today. The material list is similar to similar to the material takeoff you can do in Revit. It does give you the finished fabricated length, the length you actually need to cut to fabricate, but in terms of what's shown in that list, it's very similar to what you can do in a Revit schedule. But the assembly and delivery lists, I'll give you a quick preview of now. So it's nearly finished, and I'll get the other one running while I'm showing you this assembly list. And then just to finish off the webinar, what I'll do is I'll send it back to a new Revit file, and we'll just import it into a new Revit file because the synchronization takes a little bit longer than just importing it into a new file. But if you have everything set up correctly, you could sync it back into your main model. So this is just this is the palette I'm working in. So these are all the different types of list we can run. What I've done is I've run the assembly list. So again, it's pulled all the information through from my model information, but what this is telling the workshop is when you're making frame A1, and this is broken down into the phasing. So this is saying when you're making everything for ground floor frame module 1, these are all the assemblies you need. And then it's broken down A1, there's 2 of them. That's the weight of it. And these are all the components you need, even going down to that welded M20 nut. So what I'll do is I'll get the loading list running. So while that's running, what we can do with these lists is we can then export them into different formats. We can export them into PDF format. And then what Advanced Deal does is it creates a new folder called BOM. So that's Bill of Materials. We can export it to PDF, Word, and Excel, and all these formats here if you need anything else. So I'll send it to Excel format as well. We'll just go and have a look in that model file. So if we go back to my folder, there's my model file, and there is now a Bill of Materials folder. So everything that we create, Advanced Deal is doing the documentation automatically for me. And there's my assembly list in PDF format. So we'll just, don't need to save that, just see where it's getting. I'll show you the delivery list because I think for modular buildings, this will help the guys who are actually putting the modules together. So not the guys who are fabricating the frames, but the guys that are building the modules ready to load onto the lorries. It'll give them, it won't tell them all the pieces they need to make everything. It just gives them the items that are required in that module. So we'll just wait for this extract to create. So it's popped up on the other screen. So what this list does is it breaks it down by phase, and it just tells you the assembly number and the quantity required and the weight per assembly. So if you were assembling ground floor frame 01 or module 01, these are the assemblies you need and these are the quantities you need. And then you can obviously tick that they've been put together and received on site. And again, we can export that list. So I'll just save that to PDF as well. Okay, so what I'm going to do just to finish today's webinar off, I'm just going to send it back into Revit so you can see it in Revit with all of the connections on. So we'll put that on the desktop. We'll let that create its export. And then while we're working or bringing it into Revit, I will just run the assembly drawings just so you can see what an assembled gable end looks like, or the end of the module. So you can see the weld information that it puts on, because it puts all the weld notes on automatically for you. So we'll just let this export. I'll get the fab drawings running and then we'll import this into Revit. While this is doing the export, if anyone does have any questions, because we're going to finish in a couple of minutes, if you do have any questions, if you want to type them in now, and then once I've finished, I'll run through all of the questions, but we'll just, this export is nearly finished. Okay, so I'll save this file. What I'll do is I'll get the assembly drawings running in here. We'll go back to Revit and we'll start a new structural template. Couple of things to be mindful of when you're importing. It's always, depending on what levels and things you have set up, when I import, I do have a level 2 already, so what I'm going to do is delete this level from this model or this project, and I'm going to go to level of detail fine automatically, and just because it popped up earlier as a support case for me, just check your visibility graphics in connections. Although you can have the category structural connections is ticked, just make sure that all of the options within there are ticked as well. And we just go back to the add-ins tab. We'll choose import. It'll be this one. And again, if it needs to map any sections, it will ask you to map the sections. Because I mapped this the other day, it should, oh no, it has asked me to map a couple. So let's just load my connection in. So if it doesn't recognize anything, or it's usually if you've added connections, what it needs to do in Revit is it needs to convert it to that steel fabrication format. You just need to remap the sections. And what you can see happening here is it will just build it module by module, so it will then start putting the connections on. It'll bring the members in first, but you can see it sort of happening in real time as it builds that model. You can see straight away it started putting all the correct levels in. So those are the levels that were in my original Revit file from earlier on. Okay, so while this is importing and while it's running fabrication drawings, that sort of takes us to the end of our webinar. I will show you the finished model when it's finished, and I'll show you the assembly drawings. Does anyone have any questions that you'd like to ask now, just while it's building these couple of files? If you want to type them in. If not, we'll just wait for these imports to finish, and then I'll show you the results. And that will be the end of today's webinar. Okay, so my assembly drawings have finished running. So while Revit is importing, we'll show you the assembly drawings in Advanced Steel. So I showed you the shafts and the fittings earlier, but if we have a look at the frame drawing, you can see that it's given the positions of the fin plates, the positions of the holes. It's also given me a breakdown of everything that's required. So these are your assembly drawings. Now what my system is doing, you can see in here it's got the weld notes for my captive nut. The out of the box system, if it's a 6mm fillet weld, it won't actually display it on the drawing, because the out of the box UK system says all welds are continuous 6mm fillets unless noted otherwise. So that's why I only have a couple of weld symbols in there. Just have a look at a couple of the other assembly drawings. So that's just a couple of my 120 channels with the welded end plate on. and then the last one must be the side rails. So again, it gives me a running dimension of all the hole information. So if they were being manufactured in your workshop by hand, they can run a tape along it and just scribe off the dims, and it also notes the countersunk hole information. So those are my assembly drawings. So what we'll do, we'll just shut this down and we'll see how the Revit import is going. Okay, it's still building it at the moment. So it's got the structure in. So again, this has come back into a new file. What it will be doing now is it will be going around and putting all of the connections on. So that takes us to the end of today's webinar. If it's going to finish putting the connections on in the next minute or so, I'll just zoom in and show you the bolts and everything and show you that it's all bolted together. If anyone does have any questions, now would be the time to ask them in the connection panel. So if we have a look in here, we can go to, so the blue tells me that it's still actually populating the model with the connections, because you can see here it's still whirring around in the background, so it's still working on it. But you can see that we've got all the welds in there, the fin plates, the countersunk screws in there, the internal cap plate. So it's still building it at the moment. No one has put any questions in so far. So thank you very much for joining to today's webinar. If you do have any questions, my contact information is all over the handouts. My email address is there. If there's anything you're interested in, if there's anything you are interested in, or you want us to come and look at your modular buildings, because I appreciate that some people work with steel, some people work with timber, some people have different sections that they work with. We can set up online meetings if you're interested in looking at advanced steel, and we can run some tests on whether the workflow can be applied to your modular buildings. So thank you very much for today's webinar. I haven't got any questions pop up, so have an enjoyable rest of the afternoon.